All right, so taking a look at this question here, this one's something that can be done with the law of sines or the law of cosines. But if you put all this stuff together on the graph, you should see that we have a side-side angle situation, okay, which immediately should be a red flag that there's a possibility of 0, 1, or 2 triangles that could come out of it. Okay, all of the problems we looked at so far, there's only one possibility. So we didn't have side-side angle. So you could technically do law of sines or law of cosines here. What's nice about the law of cosines is that it'll actually tell you if there's going to be 2 triangles, rather than with the law of sines where you have to do extra work. So if I try this out here, I would have 34 squared equals to, because I use that because it's opposite the 23, so using the formula it's going to be equals 30 squared plus a squared minus 2 times 30 times a times the cosine of the included angles. In between the a and 30 is 23 degrees. Okay. So out of this thing here, as I start to work through it, trying to simplify some things, I have 1156 equals to 900 plus a squared minus 60. And I'm going to write this as cosine 23 degrees times a, right? And the reason I'm doing that is because I can see this is going to be a quadratic. So if I move everything to one side, you can rewrite it so it looks more like a quadratic. I still have this negative 60 cosine 23 as the coefficient on the second term, on the linear term, but I don't actually handle it any differently. So I'm just going to actually get my calculator to do this thing for me. Okay, so let's take a look at the calculator here. Okay, so in the calculator, I'm going to go into y equals, and I'm just going to type in, so x squared minus 60 times the cosine of 23, close those parentheses, x, because it was a linear term, plus, and it was 644. Okay, now I have to change my window so it actually shows up here, because if I graph it, I'm probably not going to see it. So I'm going to put my x max to be, say, like 50. I have no idea. I'm just guessing there, because the number seemed pretty big for the other side, so I'll just go with that. And let's take a look at this graph. If you also notice that in y equals, I also put in y equals 0, because what I'm really looking for in this graph is the 2 places where it crosses the x-axis. So in this case, the 2 places where the red and the blue graphs intersect. So remember, to do an intersection on the calculator, I just do second trace intersect, so option number 5. And there's only 2 graphs here, so I can hit enter on the first curve, second curve, because that'd be the red one. And then guess, I'm going to go ahead and move it towards this one over here. And I'm going to hit enter on that. Okay, and so I get 16.72. So here I end up with, oh, sorry, wrong one. 16.72. So A is going to be equal to 16.72, or A is going to be equal to the other intersection, which is second trace 5 there, and I'm first curve, second curve, and I'll move over towards that other intersection and hit enter on that. So I get 38.51. So 38.51. So A is equal to 35.81. Okay. So these are 2 possibilities, right? So just like we did in the law of sines work of case number 1 and of case number 2. Right? The only thing that differs between these 2 scenarios is that I now have a, see, C was 23, B was 30, and A is now, for the case number 1, 16.72, and inside C is 34. Okay? So really all we're doing here is going through and solving for angle B and angle A. Okay? So it's totally up to you how you want to go through this thing. But here, if I look at this and I do sine of 23 degrees, so that's angle C, over 34, that's going to be equal to, so you could do solve for angle A, so sine A over 16.72. So just like we did before, cross multiply and solve, and I can isolate times sine of 23 degrees, okay, and I can just divide through by 34. Okay, so here, remember, I have to use inverse sine because I'm solving for an angle here, so 16.72 sine 23 degrees over 34, and that's going to be equal to angle A. Okay, and I should use my calculator on here to get that out, and I end up with angle A to be approximately 11.08 degrees. Okay, and since we have 2 of the measures of the angles, now I can go ahead and solve for the third angle, which in this case is angle B. If I add 11.08 to 23 degrees and I subtract that from 180, I will end up with angle B being equal to 145.92 degrees. Okay, so remember, when you solve a triangle, there should be 6 pieces. We're given 3 of them, and we found the additional 3. Okay, okay. So we had this here. And now I'm not going to finish the rest of this thing here because you do the exact same process in case number 2, except in case number 2, remember, side A is going to be 35.81. Okay, so tougher problem, but still works out with the law of cosines. Okay, hope this helps.